we can see like a food web. We start with the producer, which is the grass. So many animals can eat the same grass, which they are consumer, goat, rabbit, and the mouse. After this, we can find second consumer, which is, yes, I can find jackal, wild cat, and the snake. And then the top predators, it means the apex one on the top. We can find the lion can eat the wild cat and jackal, when the kite or the eagle can eat the snake, right? So this is the food web and how can they relate it to each others. And then energy can transfer from one animal to another. So read the first question. So look at the mouse and tell me which two animals can eat the mouse. I can see two. What and what? Wild cat and the snake, right? So write snake and wild cat. So yeah, Judy. Letter B is talking about which animal get their energy directly from the grass. So now we are going to talk about the first consumer, which are all of the animals that eat the grass directly, or look at the screen, please. You can see the goat, rabbit, and a mouse, right? All of them, they can get their energy directly from the grass. Goat, rabbit, and a mouse. All of them, they are primary consumers. They can feed on the grass to get their energy. Okay, and the second question. This food web includes many food chains. Write down a complete food chain that includes the snake. So, Yalama, where is the snake? Over here. If you want to write only one food chain, we will start with the producer, right? So you are going to take this one. This is like a complete one food chain from the food web. So you are going to start with the producer, which is? What can eat the grass? What can eat the mouse in the picture? And the last? Kite. Okay, so it's like a food chain. We start with the producer and then mouse, snake, and kite, because he said bring only one food chain from this food web that contains already the snake. After that, Yaganna, rabbits eat grass that has been sprayed with a poisonous chemical. There are poison. There is a poison in this grass. Explain how the poisonous chemical reaches the body of the lion. So let's see. So this is a lion, and this is a grass which it has poison. So the lion can eat what, or what that already eat what? The lion can eat, huh? The goat? Yeah, so now the poison can go to the goat bodies and the rabbit bodies, right? And after that, when they are eaten by the jackal or the wild cat, also the poison will start to move to their bodies, yes or no? And finally, it will reach the lion. Or the lion can eat the goat directly. So what we can write, we can say, we can write whatever we want. All of them, it will be right. So we will say, number one, we will talk about the poison that we want to explain, the noun. Then we will say the poison, it will enter which body? We will say inside the goat or the rabbit. We can say the rabbit first. So the rabbit will be eaten by maybe the wild cat or the jackal, and finally eaten by the lion. Or we can explain the other part, the goat, poison inside the goat. will be eaten directly by the line. So it's according to the food chain that you are going to choose. Maybe you are going to describe this food chain from the grass to the goat and directly to the lion, or you can choose the other food chain, which is the grass to the rabbit, any one of them, jackal or wild cat, and then the lion. It's according to the way that you are going to choose. Both of them, they are right, because the poison will move from the transfer from the plants to their bodies. Have you finished? So this is about food chain and food web. Okay. So yeah, then the second page. So now we talk about physics.
Yes.
Safia mixes solids with water and observes what happens. She said, I will going to mix the solid with the water and we'll see what will happen. Solid letter A, what will happen or what is the observation when solid and water are mixed? Mixture bubbles and so now there is a chemical change. Something happened, right?
Yes.
There is a reaction because I can see bubbles. How do I know? I can see bubbles, it means gas, and also it's a change in the temperature. But when she mixes the solid letter P with the water, what happened?
Doesn't change color and stay the same temperature.
So this is a physical change, right?
Yes.
What about letter C or the solid C?
The salt dissolves and the mixture gets color.
Colder, mixtures gets colder. So also it dissolves and the mixture gets colder, it means something changed. What about letter D?
Mixture remains green.
It was green, the mixture remains green. What about letter E?
Mixture turns colorless and gets warm.
Okay, so colorless, it means there is a change in the color. So, which solids have a chemical reaction? Of course, anything will it change is a chemical reaction, right? So start with letter A. Anything change to be a chemical reaction?
Yes.
Yeah, there is a bubbles and it gets warmer. But letter B, he said nothing changed, so this is not a chemical reaction. What about letter C? He said dissolves and gets colder. So do you think gets colder also a chemical reaction?
Yes.
Yes. Changing in the temperature is a chemical reaction. Letter D remains green. It means it was green, stay as the same. But the last one, it turns colorless and gets warmer. So this is a chemical reaction?
No.
Why no? It turns colorless. It changes into colorless and gets warmer. Yes, it changes in the color and it changes in the temperature. Yes, it's a chemical reaction, right?
Yes.
Okay, Farida. Now, magnesium is added. I add, close your mic, Yazizu, thank you. Magnesium is added to what? Dilute hydrochloric acid. So dilute hydrochloric acid is like an acid. So this makes bubbles of hydrogen. So now this is a chemical reaction, Farida, right?
Yeah.
Because we can see a gas and the colorless solution of magnesium chloride. So it changed into colorless. What is the name of this colorless solution? It's called magnesium chloride. Write down the name of one of the products of this reaction. So, what can you see? He is already told us the products. He said what are the products? Products that mean what happened after the chemical reaction. Is give us magnesium in the beginning or it give hydrogen gas?
Hydrogen gas.
Yeah, he's already giving us the answer. The products they are hydrogen gas. What else? He also gave us what? Colorless solution of magnesium chloride, right?
Yeah.
So he already gave you the answer or what you need to think about it. So also you are going to write this here. So two things, they are the products for this chemical reaction. Bubbles of hydrogen gas and colorless solution of magnesium chloride. Both of them they are right. You are going to write it. It's super easy. So here, Judy, Burning wood is a chemical reaction. Why is that, ya Judy? Because wood will stay the same material or it will change into a new material.
It will change to a new thing.
So, suggest one piece of evidence that shows burning is a chemical reaction. You said burning is a chemical reaction. Give me at least one evidence that said that burning wood is a chemical reaction.
When we burn the wood, most of the wood that was it will be like.
So, yeah, Judy, let me make it simpler for you. When you describe any chemical reaction, you can mention the color, you can mention the gas, you can mention the temperature. So, what happened to the wood when you already burning it? The temperature, it will be the same?
Color change.
Okay, so change color. This is the first one, it change color. Okay, there is any gas or any smoke you can see from this reaction?
Yeah.
Yes, smoke released. There is any heat changed for burning the wood? Yes, increasing the heat, right?
Yes.
Release heat, giving heat. So, listen to me, everyone. When we are talking about chemical reaction, and he said, give me an evidence, you need to tell him about something you can see. It's a very obvious. Like, I can see some smoke or gas, I can see changing in color, I can feel some heat or changing in temperature. It's a reversible change, we cannot change it back. All of them, they are evidence. And also, you know that it's a carbon dioxide gas. So you can also say it release carbon dioxide gas because you know the name of the gas. When you burn it any wood, it will give it to you. So you can say release carbon dioxide gas. Also, this is like an evidence, right? So you are going to start to mention the points that he wanted to see in your answer. Thank you. Okay, turn the page. It's talking about physics, but this is not about chemical change. It's talking about forces. So, Yaganna, the diagram shows the forces acting on an airplane. So, of course, we are going to study the diagram first. You are going to read everything. You know that this airplane, it has already weight, which is acting downward, right?
Yeah.
And of course, we said any force has an opposite force. So weight is downward, the opposite force upward, it will be upthrust, right?
Upthrust.
Yes. And also the air resistance, because the airplane is moving forward, the air resistance, it will be backward, right?
Yeah.
Okay. So you are going to say, number one, which force is the effect of gravity on the mass of the airplane? Do you think you say air resistance or the weight?
The weight.
Yeah, because anything has mass, it will multiply by gravity. That's why we can measure the weight. So it's downward because of the gravity. So it will be the weight. Okay, letter B. So Yazizu, the thrust is greater than the air resistance. Circle what happened to the speed of the airplane. So I said, now the thrust here, this one forward, is greater than air resistance. So, do you think, circle what will happen? Do you think I will say remains constant? Or I will say decreases or increases?
Remains constant.
Why it remains constant? Why do you think that? How come, Yelby? Trust it means moving forward, Yelby. It's increase, it's more than what? Than air resistance. So it means air resistance that pushing you backward to be slow is already less. And the thrust that pushing you forward, it will be more. That's why the airplane will increase its speed, right?
Yes.
Why? Because it's pushing forward more than the air resistance. So yes, the speed will increase. Why not? You are going to look to the direction of the forces. So يا فريد, the airplane is in level flight. The airplane is not moving up or down. Level flight, it means like this level. like it is steady in the sky. It's not moving up or down. Which two forces must be equal in size? So you know, if it's steady, there are two forces that moving downward and upward to be in the same level. So you are going to look to the forces downward and the force upward. That's why the airplane will be in the same level. Which one is downward and upward?
Upthrust and weight.
Yes. So the weight and upthrust supposed to be equal. That's why it will be in the same level. That's right. So yeah, Judy, the next question. Also is talking about physics, but now returning back to chemical change, physical change, reversible and irreversible. And we have like missing spaces, we need to complete it. So, a change of state or physical change. Some of them they are physical, it means they can change the shape only, but the structure it will be the same. So, melting is a what process? Because the liquid formed can be changed into a solid by what? So melting is a physical or chemical change?
Physical.
But he's already mentioned physical change. So now he wants you to write physical or he wants you to write reversible?
Oh,
Reversible. Because he wanted you to write the other name because he said a process, not a change. So if he wrote for you a process, you will say reversible process. And he already mentioned for you, explain why melting is a physical change. So he mentioned the answer already. So all what you need to do is to write reversible. And because we can change it from liquid to solid, by what? By melting or by freezing?
by melting.
You can
By
change it from liquid to solid by melting,
freezing.
by freezing, or you can say by cooling. And letter B, Alama, describe one similarity between boiling and evaporation. So both of them, boiling, teacher, boiling, liquid to gas, evaporation, liquid to gas. So both of them, they are about what?
Liquid to gas.
It's about both of them, liquid changes
To gas.
to gas. Andy again, describe two differences between boiling and evaporation. Now he wanted differences. Okay, but both of them liquid will change into gas. But boiling,
Yeah.
I can say which one is already boiling, it will be different and then. So, boiling,
Boiling.
mm,
It
it happened.
happened in all of water.
What is the meaning of
Evaporation.
this? It means when it reached 100 degree, it will start to boil at the same temperature, right?
Yeah.
But evaporation, it happens during heating the water, so it can happen at the surface only, right?
Yeah.
So, right, number one, you can say boiling happened to everywhere in the liquid or to all the liquid when evaporation at the surface. Number two, we said boiling will happen where when it reached at 100 Celsius, right?
100 Celsius.
Happened
Yeah.
at
But evaporation in any temperature.
not at any temperature, it's among
High.
increasing the temperature, right?
Yes.
Okay, when in evaporation,
High temperatures.
yes, evaporation happen during increasing the temperature. So you need to know the 2 points. Boiling and evaporation, both of them liquid. Liquid. It will be gas. But boiling, we need to reach first 100 Celsius. All the water will start to evaporate. But evaporation, it happened during increasing the temperature, and also it can first happen at the surface of the liquid.
Finish.
Turn the page. So now we have many names in a table. So using heart rate is measured in beats per minute. How many beats in a minute? Which is beats per minute is called BPM. Beats per minute. Angelic, it's a man, investigates the average heart rate of the children in her class. Okay, Angelique, she's a woman. Anyway, she records her results in her notebook. And look at her results. Now, Priya, she has 67 beats per minute and her age is 11. So, Priya over here, all what you need to do, Yelbi, is to write the numbers. What is the age of Priya? What can you see here? 11. And of course, he said, complete this table according to the missing. So now we make what is the other average? The average, it will be between year and BPM, right? Which is the beat heart rate. Yes or no?
Yes.
Okay, so you write here BPM. Brea, it was 67. And that's all. All what you need to do is to read the names of each girl or each boy, write the age, and write the heart rate. So Maya, we are going to search for Maya over here. What is the age for Maya?
Maya.
Over here, I put a circle. It's 11 also. And how many beats in a minute? 70. Right?
7.
Now search for Lily. Where is Lily?
Lily. Lily. Here.
10 years old. How many heartbeats?
73.
Now search for Safia. Only 10 years old.
10 years old.
And the heartbeat beats.
72.
Okay, now search for Mike. How many years? 11. And how many heartbeats? 78. Now search for Oliver.
11.
And 75. Now search for Chen. 10 and 87. Now search for Ahmed.
10 years old.
And 80 for the heartbeats. Okay, it's very easy. It's about reading. But after this, of course, he is going to ask you, according to the results that you wrote in the table, another question. So, yeah, Farida, the heart rate results show some patterns. Describe 2 patterns shown by the results. What can you see? Okay, so yeah, Albi, when we compare between two things, you will compare between different things, like females and males. Look at the females' results. Do you think their heartbeat is more than male or male is more than female?
Male is more than female.
So males have higher heartbeats, right? Okay, so now you can look to the age. I have 10, 10, 10. So look at the female with 10, like Lily and Safia. They are 73 and 72. But the male for 10, they are 87 and 80. They are more, right? Now let's compare by 11. 11 for female, like Priya and Mia, 67 and 70, but males with 1178. So now the males with like lower age or less age, they have more heartbeats than the males with higher age. Yes or no?
Yes.
So you can say like younger males
Have more.
have more heartbeats than older one,
Have.
right?
Yeah.
Okay, so always we can make the comparison. We after we look to the numbers, we can read it and so on. So yeah, Judy.
Yeah.
After this, we are going. Was a biology. When you describe the heart rate and beating, your organs in your body, this is not physics. This is biology. After that, we are going to study geology. What is the meaning of geology? It means we're studying the ground. So you need know that geology it means about anything in the ground, rocks, soils, and so on. So he said soils contain water and organic plant material. That's great. We know that the soil it has water, organic plant material. What is the name of the organic plant material found in soil? So we need to remember the types of soils. So maybe we have a sandy soil, maybe we have a clay soil, maybe we have what? Hmm? Remember?
No.
Okay, we have different types of soils, Yelbi. If you are talking about the organic plant material, it's called hums. It's called what?
Hums.
Hums is the organic plant material that will store the plant to grow by using it. So the organic plant material is called hums. In Arabic, الطمي. You know, when the soil is very fertile or fertilized, it means it has a lot of hums.
Okay.
And also in the soil, you can find other parts. Like I said, we can have clay, we can have sand, and so on. So also you can find the clay and sand in the soil. So hums is organic plant material that will allow the plants to grow. You can write also we can find in the soil many things. Like we can find like pebbles, small stones. You can find dead animals, dead plants, earthworms. All of these, they are right. Have you finished?
Yeah.
Okay, after this. So, Yelama, Chen investigates the floating and sinking of object in water. So, returning back to physics. But this one in physics is talking about sinking and floating. So, he's making like an experiment. Which object will sink, which object will float. So in his first experiment, Chen measures the mass of a solid cube. Measures the mass, it means how many grams or how many kilogram, right? And then puts the cube in a container of the water. Why he measures the mass? Because maybe it's so heavy, maybe it's too light. And after this, to measure the sinking and floating, I have to drop it in water or liquid. And then he records which cubes floats or which cubes sinks. And we said to make a fair test, we have to repeat the experiment many times for different mass and of different materials. So, here is the result. If the mass of this cube is it's about 100 gram, and he did that for the wood as a material, it will float. He said it's okay. I will increase the mass. I will make this piece of wood like 300 gram, and it will be the same material as wood. Also, it floats. So he said, I will change the material. I will bring steel. And he measured the mass of the steel like 100 gram. It sinks. He said, what? It's the same mass for the wood. After this, he increased it to be only 200 and also it sinks. So now, what piece of equipment does a Chen use to measure the mass? If you want to measure a mass of any cube, you are going to use the measuring cylinder or a balance or a scale.
The measuring cylinder.
Measuring cylinder to measure the mass, like in kilograms or grams. Or you are going to use the scale, الميزان يا قلبي, or the balance, right? So you are going to use the balance scale. Why? You are going to measure the mass in grams or kilograms. You need to know the mass. So Chen thinks, he was thinking, the greater the mass of the cube, the more likely the cube will sink. So do you think he is correct? Look at the results. أول ما يقول لي كده لازم أبص على التable. Teacher, he said the greater the mass, it will sink. Okay. For the wood, he bring 100 gram, it floats. He increased the mass, also it floats. When it was 100 gram only for steel, sink. Only 200, it sinks. So now he is right or no?
Right.
He is right, يا قلبي, that he is increasing the mass. It will sink. He increased the mass for the wood, but it doesn't sink. He increased the mass of the wood, but it doesn't sink.
Yes. No.
So he was wrong. No, it's not right. It is not, or it isn't right. Why is that? You can complete the answer because he increased the mass of the wood and it floats also. So use in the table to explain. So you said he increased the mass of wood, but it floats. And also the steel, he makes it less by only 200 gram, less than the wood, and it still sinks. So it's according to the type of the material, not about increasing the mass. Okay, turn the page. So you Jannah. Chen wants to make a piece of steel float. But teacher, steel already sinks. How can we make it float? Describe he could change the shape of the steel cube to make it float, and you may draw a diagram to help you answer the question. So sometimes you can find a steel board in the boat. When you are in the boat, you can find many steel boards, yes?
Yeah.
So you can make this steel boat. It's already like a boat shape with wood. It's okay to make a boat also with it. Or you can make it like, in any air going inside. You know that the air is lighting that the water, right? So you wanted to make it lighter. So what you can do is just like draw a boat like this. And this boat is supposed to be hollow. To see like this air will go inside like this one. So this is a diagram. You will say what? I will make the steel, or we can change the piece of steel to be a boat shaped or a boat shape. Why? Because the air will go inside, it will be lighter in weight, so the water can carry it. That's all. It will be like you are teacher, I was in a boat today. It has a lot of things. There are a lot of tables, there are metals. But how can this boat is already not sinking? Because it's already hollow. Hollow in the middle, it means it has air in the middle.
Yeah.
Okay, the next question. Also, it's about physical and chemical change. reversible and irreversible. So this is physics. But now Carols adds salt to cold water. It takes 1 hour for the salt dissolve to make a salt solution. So this is like a long time, right?
Yes.
So how can Carols could dissolve the salt faster? Replace the cold water with what? We will replace the cold water with what? Use what?
Warm water.
Warm or hot water. And also, are you going to put a lot of salt? You can decrease the amount of solute, right? Yeah. And also you can stir more so you can mix them together. So stir fast or stir faster so you can mix the salt with the water faster and it can dissolve easier.
Yeah.
So Yazizu, salt solution now contains salt particles and water particles. Yes, they are mixed together and you cannot see them. So that's why I said take right the boxes. Take right the boxes next to the two correct statements. He said there are only two correct statements about salt solution. And you have to, Yazizu, you have to read the question very well. So now I know there are two correct statements. Read the first one.
Salt particles are not moving.
Do you think the salt particles are not moving?
No, they are moving.
Yeah, that's why when you stir, it starts to move in the liquid. And also it's moving without stirring. That's why it dissolves. The second one,
Water
particles surround salt particles. So they are mixing together and they are surrounding each other's?
Yes.
Yes. Water particles are moving?
Yes.
Yes, they are moving all the time. And salt particles are arranged in a regular pattern?
No.
They spread everywhere. They are not arranged in a pattern. They spread everywhere in the solution to be dissolved. Okay, the next page. So, yeah, Farida, there are three types of rock. Now we are talking about geology again. We will talk about types of rocks. Geology studying the earth, found in Earth's surface. One of the type of rock is called sedimentary. So, yeah, Farida, remember sedimentary, it means layers over layers over layers over thousands and millions of years?
Yeah.
Because water and wind can carry the layers of sediments over each other's. What are the other two types of rocks? If this rocks from the volcano, it will call what?
Igneous.
Igneous rock, yes. But if this rock buried under the ground for thousands of years, heat and pressure change it over time. It will be what? Metamorphic. So igneous rock like obsidian, like pumice, like basalt, like granite, and metamorphic that change it over time like slate and marble. Okay, so now we will keep talking about types of rocks, which is geology. So yeah, Judy, we have four types of rocks, A, B, C, and D. We said we have to read what inside the box very carefully. So the description for letter A, this rocks is found in layers and is very crumbly. It means very rough. Letter B, this rock is very hard and contains crystals inside. Rock C, this rock is black and very shiny. Letter D, this rock is soft, you can break it easily, and contains very small particles. So, which two rocks are sedimentary? Sedimentary rock, it means we can break it easily. So, which one is they are layers and you can break it easily? What do you think?
I think C and
See, it's a black and very shiny. Are you sure?
no, no, no.
Very shiny, it means like what? Like obsidian. It's igneous rock from the volcano. But which one has layers? Yes, sedimentary layers. Wind and water can make layers, right?
A and B.
B, they are hard. Only LB sedimentary, it can be broken easily. Because water and wind, they make it layers. D, yes. So the one that he said it has layers, and the one that he said it's soft and we can break it easily, like a chalk. Chalk, we can break it easily. It's sedimentary rock. Okay. The first one, layers and crumbly like sandstone, we can break the sandstone easily. It's sedimentary rock. So, after this, again, I could find this fossil in some sedimentary rock. It looks like a fossil of fish. He found it where?
Yeah.
Of course, sedimentary. Layer over layer covered the fish over thousands of years or millions of years and keep it. So, describe how fossils are formed in sedimentary rock. I just said the answer. First, sedimentary rock by volcano, or you will say that water and wind can carry sediments and layers of sediments over each other's.
Water and wind can be.
Yes, but before we said it's the layers covered this fish, of course we'll start to discuss that this fish is already died and buried immediately, right?
Yeah.
So this fish died, okay? Maybe another animal will eat it. Maybe it will start to decay. But when it died, it buried immediately. That's why it doesn't change. What happened after that? Now we can say about the layers and layers of sediments can cover it, right?
Yeah.
Okay, but teacher, if it buried immediately, maybe a part of this fish will start decay. Yeah, the flesh, the meat will start to decay. That's why we can find the bones or the skeleton. So also you can say like you can say flesh decayed, other skeleton or when skeleton is covered with layers of sediments, is covered with layers of sediments. So that's why you can imagine that you find the dinosaurs fossils like bones. You didn't find the flesh, the meat of this dinosaur, because also the flesh can decay. And after this, like layers and layers of sediments can cover it. When the layers of the sediments cover it, it will still soft or start to be hard.
Start to be hard.
And also, water and minerals in these sediments will start to enter the bones. That's why the bones will be the same. So you would say minerals replace bones. Finally, it becomes harder as a rock. It's a long answer, but it's okay. We can make it shorter. But we can just imagine from the beginning. Now this fish will die. So the fish died.
Yeah.
And after this, we have to say, okay, another animal will eat it. No, 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 no. It's a bird immediately. So we can find the flesh. No, the flesh can decay. What about the skeleton? It will be covered by sediments. But maybe the skeleton also will decay. Minerals will replace the bones. Okay, but why we find the sediments not soft? Because finally all these sediments layers and the bones becomes harder as a rock, right? Or becomes
Yeah.
hard as a rock. Okay. So now we are going to discuss what? This is about fossils. Now we are going to discuss biology. So the next page is about biology. With each question number 10. Biology, it means it's about our organs. So Yalama, inhaled air is the air we breathe in, like exhaled air breathe out. So the table shows how inhaled and exhaled air are different. So we have many gases, of course, we can inhale and exhale. We have carbon dioxide, we have oxygen, we have water vapor. So inhaled air for carbon dioxide, what is the percentage? 0.04. But do you know you exhaled? It means you are going to make this gas out from your nose. It's a 4%. So this is more or less?
and more.
More. Do you know why? Of course, because your body burned the food and the nutrients by using oxygen. Huh? Your heart get rid of the carbon dioxide by giving the deoxygenated blood to your lungs. And your lungs will breathe out the carbon dioxide to get rid of the carbon dioxide. That's why the percentage it will be less, right? Yes? Okay. So you inhaled 21% oxygen. Of course, your body will take this percentage to burn the food because we need oxygen for breathing and burning the food. That's why the exhaled air will be more or less?
Less.
Less. Also, your body, when it burned the food and you need the water, so it can release water vapor. So also your body want to get rid of the water vapor, the excess water. So that's why the percentage of course, in the exhaled also will be more, right?
Yeah.
Okay. So now he said, before reading the questions, Yelena, we said we have to read the box, we have to understand, looking to the numbers. Now we can answer easily. The percentage of carbon dioxide in exhaled air is more or less than inhaled?
More.
Is more than. And the percentage of the water vapor in exhaled also, exhaled air, is more or less than inhaled?
More or less. More.
Also, because we're going to get rid of the excess water, it will be more. So yes, Izu, explain why the percentage of oxygen in exhaled air is less. So now we inhale oxygen because we don't need it or because we need it?
We need it.
We need it in what? In burning nutrients because we need oxygen in our blood, right?
Yes.
Yeah, so because oxygen moves to our blood, yes or no?
Yes.
So what will happen with oxygen? So cells use it in what? Why we use oxygen?
To pump the blood.
To pump the blood or to burning the food. You need energy. You need oxygen to burn the nutrients and get energy. And burning nutrients and getting energy. Again, of course, the exhaled will be less because we will take this oxygen. We need it. We need it. Why? It will go through from your lungs to your heart. So it will be oxygenated blood. So this oxygen is going to where? Only in the blood? Of course, no, to all cells in your body. And why the cells need oxygen? Because it will start to burn the nutrients, because you're eating food. And why I will burn the nutrients? Because I want to energy to move, to study, to run, to speak, for everything.
Yes.
Okay, turn the page. So yeah, Farida. Now it's about physics. So let's see. Pierre sees a fish in a river. So this is physics about what? About light. Yes. So we are going, when he said a fish in the river, now maybe he will talk about the difference between air and water as different medium. So the diagram shows part of a ray of light from the fish to Pierre's eye. Complete the diagram to show the ray of light entering his eye. So this is Pierre's eye. This is the fish. Now, so do you think the light of ray is coming from the fish? Because we said the objects reflected the light, remember? Not the eye bring the light. So now when the fish reflected the light, and this light want to go out from the water, it will move from water to air. Which one is lighter, air or water? air, so the angle it will be more, so it will be like an arrow like this, a straight line. So it will be a straight line from the surface of the water to Pierre's eye. So circle what happened here. This is condensation, evaporation, reflection, or refraction.
Refraction.
Refraction, because the light will have different speed between air and water. Now turn the page. It's a new exam.